The name is Daniel, and in this one, we are going to talk about Introduction to Superposition Theorem. Now, the Superposition Theorem is saying that anytime you have a circuit appearing in this form, all you need to do is that consider only one of the sources, close the remaining sources that you have, and replace it with their internal resistance. From there, find the individual current in that circuit. After you are done, you can maintain the next circuit and close any other EMF that is in the circuit. Replace it with their internal resistance or short circuit that side of the EMF and find the individual current. Once you are done, you will now superimpose or sum up all the various currents calculated for the first EMF, the second EMF, or probably if there is another EMF in the circuit. After you finish summing up all this current, it will give you the correct value for each current passing through each branch in the circuit. So now let's consider this diagram and let me walk you through the steps. So now this is what you have to do. Before you start, the first thing you need to do is to label the current on each branch. Depending on the question given to you, you don't know where they will say you should find the current. They can say find the current through this side, or this side. So what we need to do is to label the current from the original diagram. Now to do that, let's assume that this E1 is supplying a current to this junction, and let's label this one I1. Now let's assume that this E2 is also supplying a current in this direction. So let's label this one I2. Now I1 and I2 will meet at this node. Okay, now when they meet here, they will all come through this direction. So let's label this one I3. Now do you see, I've been able to label the branch current I1, I2 and I3. The next step is that we are going to remove E2 and let's handle what? E1. Let's assume that E2 is out of the calculation. So now let's redraw this circuit and see what will happen. Now look at the diagram very carefully. We have been able to remove this E2. To do that, I short circuited this side, replacing it with its internal resistance. So let's just write short circuit here. Okay, so now that we have a short circuit here, we can solve. To do this, I will just find the branch current, okay, the direction of the branch current. So E1 is going to supply the supply current through this junction, which is, let me label it I1 prime. The reason is that not to confuse yourself, anytime you are labeling a current, make sure that you label it according to the way you did the original current, okay? Don't label this one I1 and come and label this one IX. It's only when you know what you are doing before you confuse yourself. So let's label this one I1, but to separate I1 from the original current, we use prime. So let's say I1 prime or I1 1, whatever way you want to call it. Then it will move to this junction. Once I1 prime gets to this junction, a portion will pass here, and let's call it what? I2 prime. Remember, this side 2 is I2. Now the one that will drop through this junction, let's call it what? I3 what? Prime. Now, assuming that there were values here, all you need to do is that find the total resistance and find the current what? I1 prime, which is the supply current. Use current divider rule to find 3 prime, then hold on. Now, from here, we have to close E1 and then work with what? E2. So let's redraw the circuit. When we look at the second diagram, what we need to do is to find the branch current, okay? So to do that, E2 will supply the first current, which is what? I2. The reason why I'm calling it I2 is because in the original, in that junction, I called the current I2. So I'll separate it with I2 prime prime. Now, when I2 gets to this node, a portion will drop in this direction. Okay, so this one, we will call it what? I1 prime prime. Okay, now the one that will drop in this direction, let's call it what? I3 prime prime. In the same way as we did for this circuit. Now, all you need to do is to find the total resistance. To do that, you resolve the circuit from the left to the right since the EMF is here. Okay, so when I resolve from this side, what do I need to do? I'll find the total resistance if there were individual values here. Find the supply current I2 prime prime and use current divider rule to find this and this, the current, this and what? This. Once I have done, I will now wait and superimpose the result. Now let's superimpose the result. Now, superimposing the result, we are saying that we are summing up the individual current that we have in this circuit and the individual current that we have in this circuit with what? The original circuit. And whatever value we get will be for what? I1, I2, and what? I3. Now to do this, what we are looking for is that what is the value of what? I1. Now to find the value of I1 from the original diagram, we have our I1 is equal to, now you hold on, if this is the direction of I1, then let's go to the first diagram, which is when E1 is what? Active. So let me write it here. Now, I will locate the direction of what? I1 prime and compare the direction with what? The original current. I1 has the direction here. I1 prime has the same direction, so I can write it by I1 prime. Then I'll move on to what? The second diagram. Look at the direction of what? I1 prime prime. Are they the same? When we compare here, they are not the same, so I will subtract. If they are the same, I'm supposed to what? I'm supposed to add. So I'll subtract this from what? Minus I1 prime. Whatever value I'll get will be the solution for what? I1. So now let's go to when E1 is what? Active, and let's check the direction of the current. Look at the direction of this current. Is it the same as this? No, because this direction is not the same as this. I2 prime is not having the same direction as what I, so we negate this one. So what we do is that I will say that I2 is equal to negative what? I2 prime. Do you understand? Now the next thing we need to do is to compare the direction of what? I2 with what? I2 prime prime here. Now when we compare, we could see that they are moving in the same direction. So we maintain a positive what? Current. So if I want to maintain, it's what? Plus what? I2 prime prime. Now if you know the value of I2 prime and I2 prime prime, once you add the result, it will give you the value for the what? The current I2 in that branch. In the same way, we can do for what? I3. Now let's compare. When we compare the direction, I3 is dropping in this direction, okay? It's also dropping in the same direction. So we pick the same thing, which is the positive what? Value. So I'm gonna pick what? I3 prime. Compare this direction with this one. They are moving in the same direction, so I'll maintain it plus I3 prime prime. If the directions are opposite, negate that current. Put that in your mind. So now, when I'm able to find the value of I3 prime, when I join together, I'll find the value of what? I3. And this becomes the correct current, value of current passing through what? This I3 that we have on this branch. So this is how we apply the superposition theorem to find the individual current on various branches depending on whichever current they want you to find on a specific what? Branch. So now in our next video, we are going to take a very good question similar to this one and then solve. This time it will be real values and then we will be able to understand the concept very well. So this is just an intro to this topic. My name is Daniel and subscribe to this channel. Please support this page by sharing our videos and I'll see you in the next one.